Hello everyone, I am Tanya Goyal. I am currently teaching students in one-on-one sessions. For the purpose of this video, I am taking the topic trigonometric ratios. So let's start with that. Before understanding what does trigonometric ratio means, we need to understand what does the word trigonometry means. So trigonometry is a Greek word and it is made up of three words: tri, gono and metry. So tri means three, gono means sides, and metry means measure. What we are going to measure here? We are going to measure the sides and angles of a figure. Which figure? A figure which has three sides and three angles. Can you name that figure? That figure is triangle, right? So trigonometry is the study of the relationship between the angles and sides of a triangle. So in trigonometry, we usually study a right angle triangle. Do you understand what a right angle triangle is? A triangle having one angle as 90 degree. We study a right angle triangle in trigonometry. But ma'am, why do we have to study trigonometry? We already have Pythagoras theorem for right angle triangles. Then why do we have a new branch of mathematics for that? So I will just answer this question. First, let us revise Pythagoras theorem so we can understand why do we need trigonometry, right? This is a right angle triangle, right? This is your 90-degree angle. This is your triangle ABC. This side opposite to 90-degree angle is your hypotenuse, right? This is your perpendicular and this is your base. So what does Pythagoras theorem says? That perpendicular square plus base square equals to hypotenuse square, right? Now, to apply this theorem, we need to have two sides of triangle, right? Two sides has to be known so that we can apply this theorem. What does that mean? That if we want to find hypotenuse, then we have to have perpendicular and base. If we want to find base, we need to have perpendicular and hypotenuse. If we need to find the perpendicular, then we need to have hypotenuse and base. That means two sides has to be there so that we can apply Pythagoras theorem. Now what happens if we know only one side? How? Let us consider this case. This is a right angle triangle DEF, right? And this side DE is 10 meter. The side DE is 10 meter and the angle F is 30 degrees. And we need to find the side DF and EF. How we are going to do that? Can we do this with the help of Pythagoras theorem? Can we do? No, we cannot. Why? Because we need two sides. For Pythagoras theorem, we need two sides, but we only have one. So, for this purpose, we use trigonometric ratios. Okay, so now we can understand what trigonometric ratios are. Moving on, so we have 6 trigonometric ratios. What do you mean by ratios? Ratio is nothing but numerator upon denominator, right? In trigonometric ratios, we have the ratio of two sides of triangle, right angle triangle, right? Two sides of right angle triangle. We take the ratios of two sides. So let us discuss all the 6 trigonometric ratios. Your first one is sine theta. I'm going to write the shorthand notation also. Okay. The second one is cosine theta. Your third one is tangent theta. Fourth one is cosecant theta. Fifth one is secant theta. And sixth one is cotangent theta. Okay. Ma'am, what is this theta? Just like we have variable x, y and z, Similarly, we have theta. Theta is also a variable which has a value as angle. That means theta will contain values like 30 degrees, 40 degrees, 50 degrees, right? It has angular value. All right. So let us now look at the shorthand notation of these trigonometric ratios. So sine theta can be written as sine theta. Cosine theta can be written as cos theta. Tangent theta can be written as tan theta. Cosecant theta can be written as cosec theta. Secant theta can be written as secant theta, and cotangent theta can be written as cot theta. Now, what are the ratio values of these? For this, let us consider a triangle. This is your right angle triangle. Okay. And I will name this triangle as DEF. DEF. Let us consider this angle as theta. This is your 90-degree angle. We know that this side opposite to 90 degree is your hypotenuse. This side opposite to theta will become your perpendicular, and this side adjacent to theta will be your base. Okay. So according to this, your sine theta, the ratio of sides of sine theta will be perpendicular upon hypotenuse. For cos theta, it will be base upon hypotenuse. Tan theta, it will be perpendicular upon base. For cosecant theta, secant theta and cot theta, you understand that these are the reciprocal of sine, cos and tan. What does that mean? That if sine theta is P upon H, then cosecant theta will become H upon P. Cos theta is base upon hypotenuse, then secant theta will become hypotenuse upon base. Tan theta is your perpendicular upon base, so cot theta will become base upon perpendicular. So now just look at all these ratios. Can you observe some relationship? Can you conclude some relationship out of these? Yes, we can. Now let me tell you what all conclusions can be made from this. Okay, so we can conclude three things from the discussion. The first one is that sine theta is equal to 1 upon cosecant theta. The second one is cos theta, which is equal to 1 upon secant theta. And the third one is tan theta, which is equal to 1 upon cot theta. I hope you understood the trigonometric ratios. Thank you and have a nice day.